Hey there class, Mr. Bosky here. Hope you're having a good day so far. Today we're doing 1.7 day 2, which is solving an absolute value inequality is the name of this lesson. Our essential questions are be able to write an absolute value inequality as two inequalities, be able to determine if the compound inequality is an and or statement, and be able to solve absolute value inequalities. So if you remember, if we had something like x minus 4, the absolute value of x minus 4 equals 2, we would split that from 1.7 day 1 to x minus 4 equals 2, or x minus 4 equals negative 2. If we do inequalities, we do absolute value of x minus 4 is less than 2. It's a similar thing, so we're going to do this. So less than and greater are kind of different options here, but we're still going to split it. X minus 4 is less than 2. And we're going to do and for this one, x minus 4 is greater than negative 2. So we're still going to do the 2 and negative 2, except we're also going to flip the inequality here. We're going to flip the inequality for the second one. For greater, that would be s value of x minus 4 is greater than or equal to or just greater than 2. That one would be x minus 4, is greater than or equal to 2, or x minus 4 is less than or equal to negative 2. Okay? So the moral of the story is basically you're going to use less than is going to be an and problem, and greater is going to be an or problem, and you're going to flip the inequalities and change the sign of the second one. Okay? Let's get into these actual problems here. It's probably kind of complex to think about right now, but let's get into it and make it not so bad here. All right? Steps to follow. Write as a compound inequality that is an and, that is a what? An and or statement, or what? Or. We use the symbol to decide. So greater or greater than is going to be is going to be pronounced as greater. I want you to write great and then write or in caps and underline the or. Okay, greater. Right? And then less than or equal to is going to be pronounced less than. And underline the and. Greater and less than. Okay, so what does this mean? Absolute value of ax plus b is less than c. It means the distance is less than c units from 0. Okay, so for example, we had absolute value of x is less than 3, it's saying that x is, the distance from x to 0 is less than 3, okay? The distance from x to 0 is less than 3. And we can rewrite this as this. Rewrite as, well, let's talk about that in a second here. So I have absolute value of x is less than 3, right? Let's make a number line here. So it's saying what numbers are less than 3 away from 0? Well, here's 0. Let's try some numbers. Let's try 3. Well, is 3 less than 3 away from 0? 3 is not less than 3 to 0. It's exactly equal to 3. So that's not going to work. What numbers do we have? Let's try 1. Is 1, the absolute value of 1 less than 3 away from 0? It is. 1 would work. That's correct. What about 0? Is 0 less than 3 away from 0? It is. Good. Let's go the opposite direction. Let's do negative 3. Let's do negative 2. Is negative 2, the absolute value of negative 2, if you take the absolute value of negative 2, it's going to be 2. Is that less than 3? It is. So the way this is going to work, these and problems, that's why it's less than. Basically what it's saying is whatever this is, wherever you plug into this value here, its result needs to be less than 3 away from 0, because this is 3. Less than 3 away from 0. So everything that's going to work for this is going to be everything in here. Everything in here is going to work. If you tested like 4, right? 4 would be 4 is not, absolute value of 4 is 4, and 4 is not less than 3, right? So that's not going to work. Okay? So basically it's everything that's between negative 3 and 3 for this problem. So we're going to rewrite this as, so we have negative c is less than ax plus b, which is less than c. Okay? I hope that wasn't too clunky, but yeah, so basically what it's saying what number can you plug in for x that's going to be less than 3 away from 0. And that's going to be everything that's going to be in the middle between -3 and 3. That's the range. If you try -5, -5, that's -5 is going to be 5. 5 is not less than 3. So basically, it's kind of like it's a range that's between 3 and -3, whatever this number is over here. Okay? On the contrary, we have ax plus b is greater than c. That means that the distance is greater than c units away from 0. So for that one's going to be the opposite direction, right? Here's 0. Here's 3. Here's -3. So it's saying that the value inside the absolute value needs to be at least 3 or more, 3 or greater away from 0. Well, at least greater than 3 away from 0, right? So what numbers are greater than 3 away from 0? Let's try like, here's 6, right? Absolute value of 6. Absolute value of 6 is 6. And 6 is greater than 3, right? Okay. So yeah, so that's basically what you're going to do here. So this one's going to look like this. And so it's kind of like, remember we talked about the and being a sandwich and the or being like the oars of a boat. It's the same thing here. We're going to have open circles on 3s. It's going to go outwards like the oars of a boat. Okay, so the way you write this is you're going to write this as ax plus b is greater than c, or ax plus b is less than -c. And then you're going to solve both inequalities, okay? So yeah, it's a little tricky, but if you can also just remember the shortcut here, which is this part right here and here. Make a sandwich or else do an or statement and flip the inequality. Okay, so let's go into a couple more examples where we kind of like build up to these kind of problems here. Let's go a little bit easier for ones to start, okay? So let's do absolute value of x is greater than or equal to 6. So what numbers are greater than or equal to 6? Well, if we test some numbers, let's do 4. Is 4 greater than or equal to 6? Well, I put 4 there. 4 is not greater than or equal to 6, right? That's not going to work. So, it actually just wants us to rewrite this as a compound inequality. So, and then solve it. Well, we're not going to solve it yet for this one, but let's just rewrite some compound inequalities for this one, okay? So let's break it down a little bit easier here. So we have absolute value of 3x plus minus 5 is greater than or equal to 6. This is going to be, like to do this, this is greater. Greater. So the way we're going to do this is we're going to split it. We're going to do 3x minus 5 is greater than or equal to 6. Write it normally without the absolute value symbols. We're going to put or, and then we're going to do 3x minus 5 is less than or equal to -6. And there's your compound inequality. Okay? Then you would solve these normally. Remember, we would add 5 to both sides. We're not going to do it here, but you would add 5 to both sides. And maybe we'll come back to these if we need to go through a few more examples. But this is how you write it as a compound inequality. Okay? All right, number 2. We have circle this. This is less than. Less than. So we're going to have 5y. This one's a little bit tricky. So we're going to write this as a sandwich. We're going to do 13. We're going to do between -13 and 13. We're going to do -13 is less than 5y plus 6, which is less than 13, right? Because what it's saying that this 5y plus 6 needs to be between -13 and 13. The distance between of this and whatever you plug in for y needs to be between -13 and 13. Or the whole distance is 13 away from 0, which is those two options, right? Okay? All right, why don't you guys go ahead and try 3 and 4. Just rewrite it as a compound inequality first, and then we'll do some solving for the next few problems. All right, welcome back. Number 3 and 4. So we have x plus 5 is less than or equal to 9. So we have, this is going to be, it's less than. Less than. All right, so now we're going to rewrite this as we're going to do, it's an and problem, so we're going to do the x plus 5 needs to be, the distance of x plus 5 needs to be less than or equal to 9. So that means it needs to be between -9 and 9 because that's the sandwich. So we're going to do -9, which is less than or equal to x plus 5, which is less than or equal to 9. Okay? So make a sandwich. Yeah, the absolute values, it's saying x plus 5 needs to be between -9 and 9. It needs to be less than 9 away from 0, and that's the range. Between -9 and 9, those are all numbers that are going to be less than 9 away from 0. Okay? All right, next one, number 4. We have 2x, absolute value of 2x minus 5 is greater than 6. So we have a greater. So we're going to do an OR statement. So we're going to do 2x minus 5 is greater than 6, or 2x minus 5 is less than or equal to -6. Okay, so we flip this and we flip this sign to 6 and -6. And there we go. There's our new equations. Okay, or new inequalities, I should say. All right, we have numbers 1 through 4 now. We are going to both solve these and graph them. So we'll do 1 and 2 together, and you guys will try 3 and 4 on your own, and then we'll go through these as a class, or go through them afterwards, okay? Rewrite the absolute value of inequality as a compound inequality, then solve the inequality and graph your solution. All right, well, we have x plus 4. Absolute value of x plus 4 is less than 7. So does this say less than or greater? This is a less than problem. Okay, and the less than and greater, I know it may be kind of confusing where that's coming from, but it's basically how these problems just work, and it's kind of a shortcut for you to remember how to do these problems, okay? Numbers that are, if it's saying x plus 4, absolute value of x plus 4 is less than 7 away from 0, it's going to be between -7 and 7, basically, right? So basically, we're just trying to give you a kind of a shortcut to remember how to do these problems here, okay? All right. So we have absolute value of x plus 4 is less than 7, so we're going to do, it's an and problem, so we're going to do -7 is less than x plus 4. Let me write that a little bit over here, actually. -7 is less than x plus 4, which is less than 7. Okay, now we got to solve this like we were doing in the last chapter for 1.6. What are we going to do next? We're going to subtract 4. So we're going to get -11 is less than x, which is less than, and then 7 minus 4 is 3. Okay? So let's just see what this means now. So we found this answer. Let's just plug in a number between -11 and 3. Let's plug in 0, right? We plug in 0. So we're going to do 0 plus 4. Absolute value of that is less than 7. What's 0 plus 4 going to be? It's 4. And is 4 less than 7? It is. So what it's saying is these numbers you pick between -11 and 3, if you plug those into this absolute value inequality here, those are the numbers that are worked that are going to have a absolute value that's going to be less than 7 away from 0, basically, right? So that's what that means, okay? I'm just really trying to hammer home what this means. It is kind of tricky, but just stick with me, okay? All right, let's graph this now. We're going to do a line. We're going to put 0. We have 3 and -11. I'm going to put 0 over here more. -11 is a little pretty far to the left. All right, so it's a and it's a less than, so we're going to do a sandwich. We're going to do open or closed circles on both of these. They're open because they're not equal to, and we're going to shade between. Fix that. And there we go. So this is our answer right here. All right, number 2. Absolute value of 14 minus 2x is greater than or equal to 6. So is this less than or greater? It is greater. So we're going to do greater. So we're going to do, so we're going to rewrite this without the absolute values, just normal, and then we're going to flip it and change the sign. So we got 14 minus 2x is greater than or equal to 6, or 14 minus 2x is less than or equal to -6. Solve these separately, right? So how do we solve these first? What are we going to do first? We could either add 2x or else we could, subtract 14. I like to keep x where it is for the most part and move stuff away from x. Okay, when you get to the end, let's do it the other way too actually in a second here, but we're going to get negative 2x is greater than or equal to negative, 8 divided by negative 2. So we got to flip the inequality, right? We divide by a negative, so less than or equal to 4. Or, then over here, we're going to get negative 2x less than or equal to negative 20 divided by negative 2. X is greater than or equal to 10. Okay, if you were to do this the other way, so if you were to add 2x to both sides, let's just do that over here. So we would have 14 is greater than or equal to 6 minus 4, 2x plus 6, subtract 6. 8 is greater than or equal to 2x, divided by 2. Then we're going to have 4 is greater than or equal to x, right? But when we're graphing, you need to be careful. This is saying that x is a number that's less than or equal to 4 still, right? Or 4 is the biggest number that it can be, right? So when you rewrite your inequality, when you get something like this, you want to rewrite it and switch the variable, but keep the sign pointing in the same direction. This is actually x is less than or equal to 4 when you're graphing, okay? All right, or it's saying that 4 is greater than or equal to any number that x could be, which is kind of the same thing, but I like to write our equations or our inequalities like this. I think it's a little bit easier. All right, let's graph it now. So we have this, and we're going to have, we got 4 and 10, so I'm going to put x or 0 to the left a little bit. We got 4, we got 10. It's an or statement, so, and these are equal to, so we're going to put closed circles on 4, shaded outwards away from each other. They're oars of a boat. And there is our graph. All right, why don't you guys try 3 and 4 on your own, and then also, I also have solved the last few problems. If you need more practice, we'll go back to numbers 1 through 4 on the last page, and I'll give you the answers for those too. You can try those as well and see if you need more practice. All right, 3 and 4, give them a try. Pause the video. All right, absolute value of x plus 2 is greater than or equal to 3. Is this a less than or a greater? This is greater. Greater. So we're going to do x plus 2 is greater than or equal to 3. Rewrite it without the absolute values. We're going to put or, and then we're going to do the same thing, x plus 2, but we're going to flip the inequality to less than or equal to, and we're going to put negative 3. All right, so let's solve it now. What do we do? Minus 2 from actually all of these, right? These are all the same. So we're going to get x is greater than or equal to 3 minus 2 is 1. Let me do this. Or x is less than or equal to negative 5. Graph our line. We got negative 5 and 1. We'll put 0 over here. There's 1. There's negative 5. Okay. Open or close circles on both of these. These are equal to, so they're going to be closed circles. Shaded to the left or to the right? It's an or statement, so we're going to be going outwards. Sorry, I should have mentioned that a little bit differently. Okay. So if you were to plug in numbers that are bigger than or equal to 1 or less than or equal to 5, they will satisfy this equation. If you plug those in for x, the result will be the distance from 0 will be bigger than or equal to 3. Distance from 0 will be bigger than or equal to 3. Okay? All right, last one for this page. We have absolute value of 2x minus 5 is less than or equal to 3. This is a less than problem, right? This is less than or equal to. Less than. So we're going to do 2x minus 5. Oops, actually I goofed that up. Where we're doing an and problem, it's going to be a sandwich. So we're going to put 3 and negative 3. That's what's going to be sandwiched between, right? Those are the numbers that are going to be 3 away from 0, right? So 2x minus 5 needs to be between negative 3 and 3 because those are the numbers that will be 3 away from 0 or less. Okay, now we got to solve this. How do we do that? We're going to add 5 to all 3 sides. Negative 3 plus 5 is 2. Less than or equal to 2x, which is less than or equal to 8. Divide by 2. So we're going to get 1 is less than or equal to x, which is less than or equal to 4. Draw our line. We're going to get, it's 1 and 4, so we're going to put 0 a little bit farther to the left. We got 1, we got 4. It's a sandwich, close circles. And there's our graph. Okay, so there's our answers for these problems. If you feel like you're still struggling, I would like you to go back and do these problems right here and solve these ones right here. These ones for this part right here, okay? I'm going to give you the final answers for these and the graphs in a second here. I'll do those below, okay? So go ahead and do these ones. Try to solve these ones on your own, and then we'll do the graphs. Okay, so for number 1. Number 1, you should have gotten x is greater than or equal to 11/3, or x is less than or equal to negative 1/3. And I actually didn't graph these, I guess. I just solved them. So number 2 should have been negative 19/5 is less than y, which is less than 7/5. Number 3 should have been negative 14 is less than or equal to x, which is less than or equal to 4. And number 4 should have been x is greater than 11/2, or x is less than negative 1/2. So those should have been the answers if you were to solve those and not graph them, okay? All right, thank you guys for watching. Bring your questions to class. This is kind of a hard lesson, especially just understanding like what it means. But so absolute value, like I said, what something like this is saying, if you have like absolute value of 2x minus 4 is less than or equal to 7, it's saying what number can you plug in for x that will end up with a result that is going to be at least 7. At most 7 away from 0. It's going to be 7. It's going to be less than 7 away from 0, basically. So if you got a result that was like 2 or 5 or 8, these would both be numbers that are less than 7 away from 0, right? On the number line, they'd be between. And the ones that are like that make something that's going to be between less than 7 away from 0 are going to be numbers that are between negative 7 and 7. And that's why we do the and problem, because these numbers in here are going to be numbers that work. If you have an or problem, you have 3x minus 4, absolute value of that is greater than 5. The numbers that are going to work for that, they have to be at least 5 away from 0 are going to be negative 5 and smaller, or 5 and larger, okay? It's kind of tricky, but that's kind of what it is, because you end up with 3. 3 is not greater than 5, so we're kind of finding a range of numbers that are going to work, and it's basically going to be bounded by, these numbers here, the opposites, 5 and negative 5. All right, thanks for watching, and have a great day.